In this video, we're going to be looking at how probability works when you make a choice first, and then you don't redo that same choice. Let's start with an example. For instance, you're trying to find a matching pair of socks in the drawer, but it's dark. So you're just picking one sock and then picking another. Let's say that your drawer has 10 socks, 6 black ones, 4 white ones. Now, in previous examples, we've done with replacement. Now we're doing without. And this is kind of how things really work. You don't usually pick a sock, then put it back in, and then pick another sock. Without replacement is when you pick something, you make an event happen, and then you do not return it before your second selection. You do not return the thing you pick out of that drawer. With replacement is what we've done. That's where everything resets after the first event, just like a video game. It's not really how things often work. The without replacement option, which we're doing now, is when your choice affects what happens later. It changes the world that you're dealing with, and your denominator will get smaller because there's less to choose from. Right, so what's really going on here? We're looking at dependent events. That's where two events, the outcome of the first event and the outcome of the second event, are related. The first event changes the second. The probability of A and B is the probability of A multiplied by the probability of B given A has already happened. So here we have it. A bit of a typo there. Probability of A and B is probability of A times the probability of B given A has already happened. Ignore that little I there. So here, the first choice changes what's left in the drawer. You pick a sock out. Now there's fewer total socks. It's gone from 10 down to 9 socks. So the denominator has changed. Your first choice was out of 10. Your second is out of 9. So let's try and solve this example to make it make sense. So we're taking one sock out. Then we're picking a second sock without putting the first one back. What's the chance that you get a matching pair of black socks? Okay, first we need the probability of A. What's the probability of getting a black sock? Then, what's the probability of getting a black sock for your second pick, given the first one was a black sock? So the first pick, the six black socks, there's 10 socks all up. The probability of A, the probability of getting a black sock for your first pick, easy, 6 out of 10. Now there's only 9 socks left, and only 5 of them are black because one of them has already been taken, and it did not get replaced. So probability of your second event, probability of B getting a black sock for your second one, given you got a black sock for your first pick, is 5 out of 9. And we just need to multiply those two together. That's all it says. Probability of A, 6 out of 10, times the probability of B given A, which is 5 out of 9. And that simplifies down to just 1 in 3 chance. That's a 1 in 3 chance that you're going to get a matching pair of black socks. Right, let's use a slightly different example because this rule will always work. Okay, we've got a new group. We've got 15 students. 9 are seniors and the rest are juniors. What's the probability of first picking a senior and then picking a junior? But the picking a junior depends on the senior having already been picked. So 9 out of 15 are seniors. That's pretty straightforward. If you pick a senior, though, there's only 14 students left, 6 of whom are juniors. So 6 out of 14 is your second probability. Multiply those two together, and that's how you get your without replacement. 9 out of 35. Simplified. Okay, so what we're saying here, without replacement, we're talking about when the first choice changes the possible outcomes you have later. If I had picked a white sock first, what would the chance of picking a black sock for the second event be? It would be different than if I had picked a black sock first. Okay, so can you think of an example in real life where the odds changed based on your first choice?